Hello everyone and welcome to my first prototype of my Uno solution for my NEA. Now in this first prototype, I've decided to create a text-based interface of the Uno game, and I just purely try to tackle the logic and the rules of Uno, trying to capture the essence of how the game works, how the data will be moved around. So it's not going to be any fancy visual interface as of right now. That will be happening in the future prototypes. But here it's just the logic of Uno. I have went through this before in my documentation for my NEA. So if the examiners are watching, I'll just go over through the code again, just to be safe. And if you're not an examiner, if you're just like a random viewer or you're interested in creating Uno for yourself, maybe in text-based interface, you can pause at any time and I'll scroll through the code whilst briefly explaining through each function and each line. So the whole deck function right here, and this is to construct the deck with all the unique cards in chronological order with the same rarity, which means that each card, like each value card other than 0, will be 2 of every color, 0 will be 1 of every color, and the specials or the wild cards will have 4 distinct cards in the deck. So there'll be 4 wilds and 4 wild draw 4s in the deck. But this puts it in chronological order, constructing the deck, a new deck. The shuffle function will shuffle the cards into random positions of the deck to make sure that each next card is a new and unpredictable type of card. So the users will have like a fair game. The draw function will allow the user to draw cards however much that I have decided for the user to draw. So for example, when a game usually starts, players usually stop 5 cards, and I'll just make sure that they draw 5 cards before anything else happens. If they have to draw 2 or if they have to draw 4 because the previous player played a draw 2 or a draw 4, they'll have to use this function. And if they don't have a legal move, then they will have to draw a single card. The show hand function is just a text interface on how the user will have its card selection at its disposal. And this Y value is just like, I believe it's just a number, a corresponding number. So when the user has to enter an integer input, it just represents what card is represented through what input. The can play function is just an evaluative function. It just goes over what card is legal and what card is not, and if a hand is illegal or if a hand is not. And this is needed so it can judge whether a user has to miss their go and draw a card because they have an absence of legal cards, or if the user has to have its card restricted because the card that they've selected isn't a legal card in the first place. This shows that the function of the discard cards won't be added. The illegal cards won't be added to the discard pile, which would affect other users in how they play the game and which cards and colors that they would need to play. This is the game deck. Now this is just a precursor towards the game. The game deck is just a variable where I construct the deck, and I decided to shuffle it twice. You don't have to shuffle it twice, but I did just for my own reliable benefit, just to make the randomness of the deck and the piles more reliable. The discard pile is just like a list with just initializing where the end of each list will be the most recent card played, and that will influence what color and value the users need to have in order to play their legal cards. This will be a 2D list of players in their hands. This will be a color selection for the wild cards. This is just to restrict the player amounts to keep it between 2 to 4, and here is that 5 drawing cards in the first place. Here is more where we're looking at the player turns, because we've initialized at 0 because that's where the list starts at the 0 element. And player direction just shows that it's going to go in a clockwise direction at a single increment. The discards append, we show that we're initializing a card in the first place from the deck. from the game deck after the users have drawn their cards, and that discard card will be split into a current color and a current value. And this right here is the game loop. Now the game loop, it will reveal the player's hand first, and it will reveal like the previous card dealt, just to show what's the discard card that the user has to conform to. -1 just shows that it's the last element. The can play function just is an if validation to ensure that inputs can only be made if the user has a legal card. If not, they have to draw a card and a print statement is made just to show that they don't have a legal hand. Now, for the examiners that are watching, despite my documentation being a little bit different from the screen recording, I have a valid explanation for this. When I was taking my screenshots and I was looking through the screen recording, preparing this video for you guys, I've noticed that there were some slight errors when it comes to selecting a number to play the cards. With the card chosen variable, it didn't account for any erroneous data, such as a 0 or beyond the length of the player hand. And it did not account for the fact where if you have an illegal move, it doesn't request you to be in a valid range anymore. So I needed to input this. So I needed to like create this simple while loop that just validates that just restricts the card chosen integer input, so it can't be below or equal to 0 and above the length of the list. And and it needed to also be nested within the illegal move restriction, just show that if you make an illegal move, you are still bound to the rules that you need to have a card within a valid range. Once all these restrictions are in place, and once the user has passed them all, it will display what card that they have played right here, and it will append it to the discards, and it will append it to the last position of the discard list, so that the next users can conform to it for their rules. Here's a simple winning algorithm that just gives a print statement for the winning player when they have an absence of cards. Here we're splitting the discard cards into the current color, and I've explained it through my documentation about why I've got like a length split card. When it equals to 1, the current value will equal any. And here is the functions for the wild cards, the reverse, the skips, the draw 2s, the draw 4s. And that is pretty much it. If you aren't an examiner and you're just curious why this specific line is in place, it's just to show that any value can be played once a wild card has been placed in the first place, because that's the rules of Uno. The wild card will only just change the color pile. Any value within the color constraints should work and should be a legal move for the user. Now, let's get ready to start this program. Let me just maximize it for your benefit. And here we go. Now, as I stated before, the player count should only be between 2 to 4. I selected 2 to 4 because that's just how classic Uno was played. That's how I grew up with. But you can change it up 2 to 5, 2 to 6, however you like. So let's say we just add some erroneous data, like 1, ask for sufficient range, 5, sufficient range, 8, oops, alright, 58, yeah, sure, 68, negative 98, still gonna ask for sufficient range. Now you could enter 2 players, but I'm going to enter 3 and 4 players because I want to showcase all of the card functions in its glory. And with the reverse function, reverse just makes the turns counterclockwise. So whilst the computer will register it as like a reversed moveset between player 1 and player 2, as an output, it's just still going to look like a back and forth between both players, which won't be visible for us. So with 3, it'll just with 3 or 4 players, it'll be much more easier to visualize it, how the reverse function will work. So I'll just select 3 players. Now this top list right here is the player 2D list. You can see it's been segmented into 3 sublists because we've inputted that there'll be 3 players, and each of them are having 5 cards. This list is a split of the discard card, and it's split to show the current color that we need to conform to, which is a red, and the current value which we need to conform to, which is a 9. And here is our player 1 interface, player 1 hand interface, and we can see that we've got the selection of cards at our disposal. Since we didn't have like a red or a 9, player 1 had to skip their go and they had to draw cards, so we immediately went to player 2. Now, player 2, because we have a green 9 and we have a red 8, so those are our 2 legal cards. Now let's try entering some erroneous data first of all. If we do 0, it's going to ask for a valid range. If we do 9, valid range. Something close to the boundary like 6, valid range. And if we do 5, it's not going to ask for a valid range. It's going to say that it's an illegal move at that point. Now, the issue that I already spoke about how it doesn't conform to the valid ranges beyond the legal move, I managed to fix that. And if we try to do like another one like 6, it's going to go back to enter a number within the valid range. Negative 23, number within the valid range. 2, illegal move. So now that that's dealt with, we should just do red 8. And now we've gone to player 3. Now player 3 has a red reverse, a green skip, a yellow 8, a blue reverse, and a red 3. Now let's try do a red reverse. Now for the red reverse cards, what should be happening is that we should go back to player 2 instead of player 1. So if we hit 1, we'll do player 2. Now player 2 didn't have a red or a reverse card. Hold on, I just scrolled a bit. So player 2 didn't have a red or reverse card, so I had to draw a card, and then I went to player 1. Player 1 didn't have a red or reverse, so I had to draw another card, and we're back to player 3. Now, if we do a blue reverse, it should be moving this turn back to player 1, a clockwise turn. But before we do that, I just want to test out the erroneous data of the integer selection once again, because now instead of having 5 cards, we're having 4 cards. We're having less than the default. Whoops, sorry. Just to show, if we do 5, that was our default boundary data. It's not within the valid range. 0, not within the valid range. If we do a 2, it's an illegal move. And if we try to do 5, there we go. We've got all our validations in place. Everything's working perfectly. So now let's play our blue reverse, and it should go to player 1. Now you can see player 1 has successfully drawn its cards. You can see here that it previously it had 6 cards because it missed its go on its first moment, and it drew its card because it doesn't have legal cards, and now it's got 7 cards now. So you have a blue reverse and just a few number cards. Let's play blue 5. Now we go on player 2. Player 2, the only thing that will work for it is blue 7. Player 3 can't play. Player 1. Oh, I also forgot to mention. Now we can also test what will happen if it's beyond our default card selection, because we've got like more than 5 cards at this point. So if we do 6, whilst it should be an erroneous data at the get-go, but here it'll print that it is a legal selection, but it's an illegal move. And if you do 7, that's when the data becomes erroneous. 0, same case, and there we go. So we got blue 7. We should probably be playing a blue 4. That's what I would select. Player 2 doesn't have a card, a blue or a 4. Player 3 has a blue 7. That's the only card we can pick, so let's just play that. Player 1 has a blue 3. Player 2 has a, let me see, oh yeah, a yellow 3. Player 3 has a yellow 8. Player 1 has a a yellow 0. Player 2 can use only can use a yellow reverse. Player 3 doesn't have a card, so he needs to draw. Player 2 just has to draw. Player 1 has to draw. And now we've got player 3. Player 3 can only play yellow 8. Player 2 can only play yellow 5. Player 1 doesn't have a legal card. Ah, here we go. We've got something new here. We've got a wild draw 4. Now with wild cards, we should be getting a color selection. Now for a purely wild card, we'll only see a color selection, but we're at the wild draw 4. After the color selection, the subsequent player, which should be player 3, should be forced to draw 4 cards. Since it's already drawn a card because it missed its go, it currently has 3 cards at its disposal. So when we hit 4, it should be having 7 cards. So let's press 4 and let's make it green. And you can see here it has 7 cards. Now we've got a new function as well. We've got a skip function. So if we hit a green skip, what should happen is that player 2 should miss its go and should go to player 1. So let's do that. And player 1 is there. So let's reverse it. This should go to player 2. Player 2, if we do a green skip, it should skip player 3 and go to player 1. Player 1 can play green. Player 2 can play like green. Player 3 can't play a card. And player 1, now that we've got like 1 card in our hand and we're about to play it, as soon as we play it, player 1 should be displayed as the winner. Game over. Player 1 is the winner. Press any key to continue. So there we go. It works. However, we were missing the showcase of a draw 2 and a singular wild card. So let's carry that out. Let's first do 2 players just to show what it will be like with 2 players. You can see that the 2D list of players has been segmented into 2 sublists. We've got our card here. And if we do like, let's say, a yellow reverse, it just goes back to player 2. Like I stated. Player 1 can play yellow 9. Player 1 has to do like a wild draw 4, and green is the only sensible option. There we go. We first have our wild card. Now, when we enter this wild card, it should only present us with a color selection, and it should not impact player 1's hand at all. This means that player 1 should continue to have 3 cards after this wild card. So let's do a 7. 7, and let's try do a yellow. Player 1 doesn't have a yellow, so it has to draw a card, but you can see that it still had its 3 cards right after that turn. So player 2 can use a yellow 5, and player 1's got its green 5, green 1, green 4. Now, if we do a green skip here, it should skip player 2's turn and should go back to player 1. So if we do a green skip, it's player 1's turn. We do green 4. The only legal move is a green 5 or a blue 4. So I'll just do a blue 4 because I want to also show what will happen if you have a draw 2 card, and we'll use 4 players to maximize our chances of getting a draw 2 card. So do 4, and player 1 should be the winner. Played blue 6, game over. Player 1 is the winner. So we're using 4 cards. You see we got our 4 sublists. We've got our draw 2s. We've got a red 4. Okay, now with the red draw 2, we should be seeing player 2 having to draw 2 cards. So it will get 7 cards in total because they each have 5 cards at a default level. So we get draw 2. And we can see that player 2 has 7 cards. So let's reverse it. This should go back to player 1. And player 1 can't play a card, so it goes to player 4. Then it goes to player 3. And player 3 can just I believe the only card at its disposal it can play is just a red reverse. So it goes back to player 4. Player 1 can't draw, and it's back to player 2. Player 2 will probably play like 5. Player 3 can't play 5. Now for player 1, if we do a yellow draw 2, this should go back to player 2. Player 2 had to draw his cards. Let's just scroll. So we can see that player 2 had 5 cards. It dealt 1, so it only had 4 at its disposal. So when we force the player 2 to draw 2 cards, it should have 6. And if we do green draw 2, player 3 has to draw 2. Green. Player 4 has a yellow 9. 6. And if we enter this, then player 4 should be the winner. Game over. Player 4 is the winner. So there it is. This is a text-based Uno. It worked just as expected. And I hope you enjoyed this prototype. I hope you enjoyed this showcase. And if you aren't here for the NEA, I hope you found this quite interesting and informative. So there, see ya.